Hi all, see this. This is a problem regarding the limit definitions, and obviously we are asked to calculate the right limit, not the total limits, right? Because it's a right limit because 0 plus. So we just convert with a normal approach first, right? Because that's the easiest way. So let's so we first take that. So here we'll get that my right limit P is equal to limit x tends to 0 plus 1 plus tan square root x whole to the power 1 by 2x. That's it. So here, if I use the definition of the right limit, we can say that it is limit h tends to 0, 1 plus tan square root h and 1 by 2h. That's it. So now, obviously we can see that this can be easily solved using 1 to the power infinity formula, but we don't use it here. We just go ahead with a normal procedure, okay, which are only there in our NCERT book. We just solve that based on that only, okay. So let's see that here we can apply that log from both sides. So we take natural logarithm. So taking logarithm both sides, we can say ln P is equal to limit h tends to 0 2h log of 1 plus tan square root h. That's it, okay. So we just apply the power law in log and rewrite that. So we just step one step ahead, okay. Now see that here we have that concept, right? Now see that here it is h tends to 0 and we have root h, right? So why should I make our life difficult? So here we take a substitution. What's that? Let us take square root of h as anything. So let's y, right? So we'll say that take square root of h is equal to y. That imply that h is equal to y square. That's imply that h tends to 0 imply y tends to 0. So therefore the limit, now we'll convert it to y, okay. So let's go ahead. So therefore we'll say that ln P is equal to limit y tends to 0 log of 1 plus tan square y divided by 2y square. That's it. Now that can be easily written as limit y tends to 0. 1 plus tan square y means it's 6 square y. So therefore it's 6 square y divided by 2y square. Again we can apply power law. So therefore it's limit y tends to 0 y square log of sec y. That's it. Now how we apply that? See that we have 6 square y. So that 6 square y, right? So these two will come outside and 2 and these two get cancelled, and that's it. Now see that if I apply the limit now, this is 0 obviously and this is 6, 0 is 1, log of 1 is 0. So therefore we can say that this is definitely in the form of 0 by 0 form. Now as it is a 0 by 0 form, so therefore we are allowed to apply L'Hopital rule, right? So that means we will differentiate the denominator and numerator together, right? And that's it. So let's do the differentiation. So if I go ahead and take the differentiation, we'll say that limit y tends to 0 2y, and then we have 1 by sec y and sec y tan y. Because ddx of sec x is sec x tan x and log x is 1 by x, right? So we apply the chain rule as well, okay. So now sec get cancelled, so therefore the given limit like ln P is equal to limit y tends to 0 tan y divided by 2y. So therefore it's 1 by 2 limit y tends to 0 tan y by y. Now this tan y by y is a standard limit. Now as it is a standard limit, we all know that is 1, otherwise you change it to again sin y by cos y. So sin y by y gives you 1, 1 by cos 0 gives you 1. So again you can apply that. So so therefore this value is 1 by 2, and that's it. So therefore the required problem, the ratio of LNP, or the LNP value is not ratio actually, that is half. So see that here we just apply that logarithm and all that stuff, and we just go ahead. But in this case you can apply that in limit formula or the techniques for 1 to the power infinity form, right? So that's way also you can calculate, which reduced your little bit effort, but that's it. More or less you will give spade the same time. Okay, so that's it. Hope you understood the problem. Thank you.